right, so for the second part of this lesson, we're going to talk about graphing piecewise functions and building piecewise functions from problems. So I have this piecewise function here. So it's 2x plus 3 for x is less than or equal to 0, and then 1/2 x minus 1, where x is greater than 0. So to start, I'm going to start by graphing this first piece, 2x plus 3. I need to think what is my endpoint. So what I'm going to do is, since my domain is cut off at 0 here, I'm going to evaluate this first piece at 0 to see where I start. So I'm going to do f of 0. So I got 2 times 0 plus 3, which gets me 3. So I know that this point is going to end at 0, 3. So 0, 1, 2, 3. And it is going to be a closed circle because it is defined at 0 following this rule. And now it follows this rule for where x is less than or equal to 0. So I know less than is going to be going to the left. So what I'm going to do is I'm going to work with my slope of 2 and know that I'm going to the left. So I need to use my slope of positive 2. So I'm going to be going down 2 and then to the left 1, down 2, left 1, down 2, left 1. And I'm just going to keep following that pattern. Connect that. So there's my first piece. Now for my second piece, I got 1/2 x minus 1 for everything that is greater than 0. So to see what point is my starting point, I'm also going to evaluate this piece at 0. So I have 1/2 times 0 minus 1, which gets me 0 minus 1, which is negative 1. So the starting point for this piece is 0, negative 1, and it is an open circle here because it's not defined at this point. So I got 0, negative 1. And now it's for everything greater than 0, so I'm going to be going to the right, and I'm going to be working with that slope of 1/2. So I'm going to go up 1, right 2, up 1, right 2, and I'm just going to keep going with that pattern. And then you can go ahead and connect that. And there is your piecewise function graph. All right, now working with 3 pieces. So I'm going to start, I got this first rule is 2/3 x plus 3 for x is less than or equal to 0. So to find that starting point, I'm going to evaluate that piece. So I got 2/3 times 0 plus 3, which is 0 plus 3, which gets me 3. So I got, since I plugged in 0, I got 0, 3 is my starting point again. And it is a closed circle there because it's defined at 0. So I'm going to work with that slope of positive 2/3, but I have to go to the left, so I'm going to be going down. So down 2, left 3, down 2, left 3, down 2, left 3. So there's my first piece. My second piece is the rule 3 for 0 is less than x, which is less than 2. So when you have a middle interval, you are going to have to evaluate both endpoints. This one there is no x, so it's not as bad. But I have the points. The first endpoint is that 0, 3, and then the second endpoint is 2, 3. And both of them are going to be open circles because they're not defined at 0 or 2 there. So it does happen that the first piece does run into the second piece here. That does happen. It doesn't always happen though. We got 0, 3, and 2, 3. And then I'm just going to connect that right there with the line y equals 3. And now for my last piece, negative 1/2 x, I need to find my starting point. So I'm going to do negative 1/2 times 2. Negative 1/2 times 2 is negative 1. So I have a starting point of this piece of 2, negative 1. And it is a closed circle here because it is defined here at 2. So I'm going to go to 2, negative 1. Got that. And now I have a negative slope, but I have to be going to the right because it's everything greater than 2. So I'm going to be going down 1, right 2, down 1, right 2, down 1, right 2. And then there is the last piece of that graph. Okay. Now writing graphs, or writing functions from their graphs. So these are all linear, so we need to find 2 pieces of information. I need to find the slope, and I need to find the y-intercept. So if I start with this first piece, I got a slope. If I look from -1, 1 to 0, 0, if I were to calculate that slope, that gets me a slope of -1. And again, if you need that reminder, that slope for that piece would be 0 minus 1 over 0 minus -1. Change in y over change in x, which gives me -1 over +1, -1. And then my y-intercept is clearly 0. So reminder, y equals mx plus b is what we're going to be working with here, where m is the slope of the line and then b is your y-intercept. So I have the first piece of this piecewise function, f of x, is -1x plus 0. We can just write -x. And now we need to define what piece of the domain is for. So we're talking about this with respect to x. So it starts at -1, and -1 is included. So -1 is less than or equal to x, which is less than or equal to 0. And now the other piece. So I have this other piece right here. So if I do the slope of this segment, I get change in y. So 0 minus 1 over change in x, which is 0 minus 2. So -1 over -2 gets me a slope of +1/2. And then my y-intercept is also here, clearly 0. So the second line is 1/2 x plus 0. So we can just write 1/2 x. And this is from when x is 0, which is less than x, which is less than or equal to 2. And the reason that we don't define it at 0 in that second piece as well is because it can only be defined at one spot. So since I already defined the function at 0 following my first rule, I'm not going to do it again for my second rule. So there is my piecewise function. And now to its domain. So we see that its domain, it goes from -1 to 2 inclusive. So we're going to put those brackets. And then the range is from 0 up to 1, inclusive of both as well. Okay, so now going to my next one. So I see I have 3 pieces here that I need to work with. Okay, and we're going to throw arrows on those as well. All right, so I need to find the slope and the y-intercept of each of these lines. So I'm starting here. So I got my first piece. So to find the slope, I'm going to pick 2 points, and then I can do my rise over run. So I'm going up 1, 2 over 1. So I see that I have a slope here of +2. And then a lot of people think that there is no y-intercept here. Just because it doesn't touch it, the segment does still have a y-intercept if I were to go ahead and move or extend that line. So I need to keep working with that slope of +2. So from the point where it stops, I'm going to go up 1, 2 over 1 again. And so I actually see that this y-intercept is 3. So that first piece is 2x plus 3. And this is for all x that is less than -1, because we see it stops at -1, and it is not inclusive because it has that open circle on the graph. All right, so then I'm going to go ahead to my next piece. So I got right here. This is just that nice line, y equals 1, so it just follows the rule 1. And now I need to define it for its domain. So it starts at -1, it's not inclusive, and then it goes up to +1, and it is defined at +1 because of that closed circle, so less than or equal to 1. And now I need to do this last piece. Got this last piece right here. So first thing I need to do is find my slope. So I'm going to pick a point. I got up 1 over 1, up 1 over 1. So I see that this slope is +1. And if I were to extend that line back to my y-axis to see what the y-intercept is, I go down 1, left 1, I would see that that y-intercept is actually 0. So this is just the line y equals 1x plus 0, which is just x. And now for its domain, this is for everything that is greater than 1, because we already defined it at 1. And now my domain. So I do have this hole in my graph at -1, so that is the only piece that is not defined. So I got from negative infinity up to negative 1, and then in union with negative 1 up to positive infinity. And then my range, since I have an arrow going up and an arrow going down, I got that this is negative infinity to positive infinity as my range. Okay. Now we got word problems. So in the summer of 2009, Duke Energy supplied electricity to residences of Ohio. The company charged for a monthly customer charge of $4.50 plus all of that per kilowatt hour for the first 1,000 supplied in the month, and then that 0.05 per kilowatts for all usage over 1,000. So I want to start by expressing this as a piecewise function. So I'm going to build this C of x. So I'm going to be focusing on this first piece here. The company charged a monthly customer charge of $4.50 plus that amount for the first 1,000 kilowatts per hour. So thinking about this linear function, I have that fixed cost of $4.50, that's like my y-intercept, and then that 0.042345 is like my slope. So this is 0.042355x plus 450. And it's for the first 1,000. So this is going to be for everything x that is less than or equal to 1,000. Because it could be 300, it could be 500, and it's going to follow this rule. Okay. Then, though, it tells me that I have this extra charge for all usage over 1,000, 0.053622 per kilowatts per hour over the 1,000. So what I first need to do is I need to find what is the cost for 1,000 of them. So I'm going to do C of 1,000, which is 0.04235 times 1,000 plus 450. And that gets me 46.85. So that is the charge for, again, 1,000 kilowatts. So that is already kind of quote unquote what is paid. So for everything over that 1,000, it's going to be that 0.053622. So that's my new slope. But since the first 1,000 kilowatts have already been paid for, I don't overcharge, I don't double count for those 1,000. So what I'm going to do is I'm going to call this x minus 1,000. Because, for example, if you only want 1,100, if you used 1,100 kilowatts per hour, you should only be charged for that extra 100, not that extra 1,100. And then this 46.85 is what was already paid for. So plus 46.85, and that is for everything over 1,000. And there is your piecewise function. Okay. So the charge for using 300 kilowatts per hour, so that's going to be following that first rule. So I would do C of 300, and that's 0.04235 times 300 plus 450. And that would get me $17.21 when you round that. And then if you use 1,500 kilowatts an hour, that's going to be following that second rule. So I got 0.053622 times 1,500 minus that 1,000 plus 46.85. So I can do that subtraction really quick and get 500 plus 46.85, and now I'm just going to evaluate this guy. 0.05. And that would give me a cost of about $73.66 when I plug that into my calculator. All right. All right, next one. Sprint PCS offers a monthly cellular phone plan for $39.99. The plan includes 450 anytime minutes and charges an additional $45 cents per minute for additional minutes. So if C is a monthly charge for X minutes used, we're going to write a piecewise function that models this. So this one is actually easier than the last one because I have a constant and then I just have something being added on after it. So I get 450 minutes for the regular plan, and it's only going to be $39.99. So if I use 1 minute, it's $39.99. I use all 450, it's still $39.99. So my first rule there is $39.99. And this is for when x is less than or equal to 450. But then for every additional minute, I get charged 45 cents. So that becomes now my slope of my second piece of my function. But again, just like the top, I already paid for the first 450 minutes with that $39.99. So this is gonna be 0.45 times x minus that 450 that's already been paid for. And then what has already been paid for it is $39.99. And that's gonna be for everything greater than 450. All right, so if someone uses 300 a month, so again, that's C of 300. Since that's less than 450, it's just $39.99. And then if somebody uses 500 minutes a month, that is gonna be following that second rule. So 0.45 times 500 minus 450 plus $39.99. I can do that subtraction really quick. So 0.45 times 50 plus $39.99. Which gets me $62.49.